Hi, my name is Kelly Chow, and today I will be talking about the popular science article Experimental Brain-Computer Interface Translates Brain Signals into Recognizable Speech. The bioinformatics method used in this article is deep neural networks, and my audience is the BIMM143 students. So the scientific question investigated in this article was, can neural activity be used to reconstruct speech from the human auditory cortex? And the hypothesis was that the intelligibility of auditory stimulus reconstruction can be increased by using advances in deep learning and speech synthesis technologies. Before we delve deeper into deep neural networks, we should first learn some key terms. A vocoder is an instrument that analyzes and synthesizes human speech. A deep neural network models the structure and function of the brain. It consists of multiple layers between the input and outer layers. Each layer is made up of neurons with synapses and activation functions connecting them. One popular activation function used for deep neural networks is the sigmoid function, which is a mathematical function that looks like an S-shaped curve. The sigmoid function will be used in the Keras model we will see later, which is a bioinformatics model that groups layers into an object with training and inference features. There are three factors that affect speech reconstruction accuracy. The first is the regression technique, either using a linear regression or using a nonlinear deep neural network regression. Second is the representation of speech. We can use auditory spectrograms or speech vocoder parameters. And the last is the neural frequency range, either by using a low frequency or versus a high gamma envelope. The experiment discovered that the deep neural network vocoder system sounds the closest to natural speech, and it accurately reported the gender of speaker compared to the other methods. Intelligibility also increased by 65% when comparing results from using the deep neural network model versus linear regression. So why is this important? Speech recognition can help accomplish many important achievements. The ultimate goal is to help people who have lost their ability to speak by creating a direct communication pathway to the brain. An additional benefit is through technology like Amazon Echo and Apple Siri. Having voice-activated technology can be very useful when it's inconvenient for someone to use their hands. Previous research have used many representations of speech, such as auditory spectrograms and speech vocoder parameters. They have also been represented by discrete units like phonemes, phonetic categories, and words. However, different representations of speech will produce varying results of accuracy. For example, discrete units don't capture important aspects of speech, such as emotion and intonations. On the other hand, reconstructing continuous speech will give real-time continuous feedback, and this makes it easier for the brain-computer interface algorithm to adapt and gain better accuracy. Although research has been done, there are still limitations to speech reconstruction. The workings of the brain is very complicated, which is why it's difficult to measure, and also ethics prevent us from using invasive methods to measure the brain. In Figure 3 from the original research article, we are able to compare the results of using different representations of speech and linear versus nonlinear deep neural network regression on accuracy. In the experiment, participants listened to digit sounds spoken by two male and female speakers. They were then randomly assigned to four groups of light blue representing linear regression with auditory spectrogram representation, purple on the graph representing linear regression with vocoder representation, pink representing nonlinear deep neural network regression with auditory spectrogram, and red representing nonlinear deep neural network regression with vocoder representation. They then reported the digit, the quality of the speech on a scale, and which gender they thought the speaker was. In all three aspects, the deep neural network vocoder design, shown in red, had the most accuracy and the highest opinion score. The bottom four diagrams illustrate the digit confusion patterns by comparing the actual digits versus what the participants perceived. As the last deep neural network vocoder has a clear diagonal line, we can conclude it had the least amount of confusion. This example Python code of using the Keras model for deep neural networks is from machinelearningmastery.com. The first three lines of code import packages from NumPy and the Keras model to use later. Line 6 then loads the data from a file that is then split into the input data in line 8 and the output data in line 9. Line 11 initializes the Keras model, while lines 12 to 14 each add a layer of neurons. The first parameter indicates how many neurons are in the layer. So there are 12 neurons in line 12, 8 neurons in line 13, and 1 neuron in the layer in line 14. And the last parameter indicates which activation function each layer uses. Line 15 compiles the Keras model, while line 18 fits the model on the dataset. And then we can also use line 20 to make predictions with the model. And if we want to see specific cases, we can print them out like in lines 22 and 23. Some questions we can think about for the future are, what advantages does using the Keras model have? What disadvantages does using the Keras model have? And how would deep neural networks be implemented without using the Keras model?